We're going to be talking about the surface area of solid 3D figures. Okay, today you will learn how to find the surface area of 3D solids. It is no different from how you found it back in geometry, okay? So really and truly, it's more like refreshing your memory, okay? If you have done surface area, volume will be next class of these three-dimensional solids. Okay, so we'll start out by talking about each one of the solids. You will need to be able to recognize them when it comes to a problem, and then of course find the surface area and volume, potentially having to use some of the geometry concepts that we talked about already, such as SOHCAHTOA, law of sines, law of cosines, and even area of triangles as well. Okay? So, a prism, okay? You have different examples of prisms. You have a cube, you have a rectangular prism, you have a triangular prism, okay? For the cube, each base of the cube is a square. For the rectangular prism, each base is a rectangle. And for the triangular prism, each base is a triangle. Okay? So you name your prisms based off of the base. Okay? So a prism is a solid with two parallel congruent bases joined by faces that are parallelograms. Okay? So whatever the bases are, again, that's how you name that particular prism. They are congruent, and they're joined by parallelogram faces, okay? And again, a prism is named by the shape of its base. Very good, okay? A lot of times you guys are going to be working with these two different types. You're usually not going to work with a pentagonal prism or anything higher than that. So you're definitely going to need to make sure that you're able to find the surface area and, or the area of those two different shapes. Okay? The surface area formula of actually I'll hold off on that way. A pyramid. Okay, you have a triangular pyramid, a rectangular pyramid, a hexagonal pyramid. Okay? Again, a pyramid is a solid that is a polygon, and the sides are what? The sides of each pyramid are in the shape of what? Triangles. Triangles that meet at the top. That top point is called an apex. That top point of each one of your pyramids is called an apex. Okay, and two, just like a prism, a pyramid is named by the shape of its base. Okay, so it's a triangular pyramid or a rectangular pyramid, a square pyramid, etc., etc. Okay. A cylinder, kind of like a can of green beans. A solid cylinder has a curved surface and two blank bases that are blank circles. Two what bases? The top and the bottom of the cylinder, they're going to be what? They are going to be circular, okay, hence the circles part, but the two bases are also going to be what? They're going to be congruent, okay? There are congruent circles, and they're also going to be what? Parallel. What? Yes, parallel, right? You never went to the store and got a can of green beans that was slanted, right? If you did, you probably were like, okay, I'm not buying this can of green beans. I'm gonna get the regular, parallel base one. Okay? So that's two parallel bases that are in the shape of circles, and yes, those circles are congruent. The radius of a cylinder is the radius of one of its bases. And the length of the cylinder is the perpendicular distance between the two parallel blanks. What's the only thing that hasn't been talked about in this picture? The height. The height of the cylinder is the perpendicular distance. Perpendicular means what? Intersects to form a 90-degree angle. So the height, which here is on the outside, but the height also goes from one center of the circle to the other center. It does create a 90-degree angle, and it's between the two parallel bases. Okay? You're not going to be working with too many oblique solids where there are slanted. Majority of them are going to be right. Okay? Right cylinders, right pyramids, etc., etc. A cone, similar to a cylinder, has a circular base a curved surface, and by curved it means basically that it wraps to form the sides and one blank. We already have it. Cone has a circular base, a curved surface, and one apex or vertex. Okay, vertex, apex, same thing. The curved surface of the cone is also called the lateral surface. Does anybody know what lateral means? In opposite directions. That's straight. That's vertical. Not in the middle. Not slanted. Does anybody watch football? Like when the quarterback makes a lateral pass, he's throwing the ball. No. Wow. What am I doing? I'm throwing the ball to the what? To the side. Lateral means side. Okay? So the sides of your cone, okay, it's called the lateral surface area, okay? Because it's around the sides. Alright. The height of a cone is the distance from blank to the center of the base. Where does it come from? Look at that picture. The height of the cone is the distance from the blank to the center of the base. Vertex. From the vertex, also known as the apex. Yep. The blank height is the distance from the vertex to any point on the circumference of the base. Slant. Yes, the slant height. Okay, so there's a difference when you're dealing with the cone between your slant height and your regular height. Okay, please recognize the difference. All this is coming back, yes? Hope so. The last one out of your three-dimensional solids, okay, is a sphere. A sphere is entirely curved. It's an entirely curved surface. Every point on the surface is equal distance from the center of the sphere. Okay? Like a basketball, a baseball. The distance from the center of the sphere to any point on a surface is called the radius, okay? And the radius can go to any point along the sphere. It doesn't have to go straight through what's known as the great circle. The great circle is kind of like the equator of the sphere, okay? It doesn't have to always be there. It could be anywhere. And it's always the same. It's always congruent. Now, if you slice a hemisphere in half, what are those called? That's for 2D. So now it's 3D. A hemisphere, right? Like think back to when did you first learn about like the globe and how it worked? Did you learn about the northern hemisphere and the southern hemisphere? Okay.
I was just called it dome.
Southern hemisphere, okay. And if you notice, when you cut it in half, okay, one thing you have to be aware of is like you have half of basically the curved surface area of the sphere, and you also have a circle in the bottom. Okay, so think of like you had like a little ball of butter, right? When you cut that ball in half, don't you have that flat surface where you just cut? Okay, you have to remember those types of things, especially when you're doing surface area. You got to be very careful. Okay, these are all your three-dimensional solids. We're going to talk about surface area today, volume on Friday. Okay, so going back to your prism, flip it over.
What's the difference between area and surface area?
Well, area is for your two-dimensional shapes. Surface area is for your three-dimensional shapes. So you're covering all the surfaces of that three-dimensional space. Whereas 2D, the area is literally of that plane figure. Now, in this particular case, you have a right prism. Okay? It just says the ABCDEF is a right prism. BE is 4, so I'm going to go ahead and label that. And the triangle ABC is isosceles with AC equaling CB, which equals 3 centimeters. So I'm going to go ahead and label that as well in my picture. And angle BC CA is 120 degrees. So this angle right here is 120 degrees. Questions up to here? It's going to ask us to find the area of this triangle. Like I said, you're going to be using some older concepts that we've talked about in here, such as finding the area of a triangle. Is this a right triangle? Do not try to make it into a right triangle. You're going to create a lot more work for yourself than what you have to. Okay? But there is a formula to find the area of any triangle. What's that formula? 1/2 AB sine C. It could also be 1/2 BC sine A. It could also be 1/2 AC sine B. It could even have different letters in A, B, and C. Okay? But basically, A and B represent what? Your sides. And C, angle C represents what?
The angle measure.
The angle that's where?
In between.
In between both sides. Okay? So really and truly, it's more like 1/2 side, the sine of the included angle. That's really what it is. So, as we do this, we're going to do 1/2 the two sides times the sine of the angle. What are my two sides that I'm going to use? The threes. 3 for AC, 3 for CB, and then we're going to take the sine of what angle? 120. So let's go ahead and type that into our calculator and figure that out. Do we get an answer?
Yes.
Was that your answer?
Yes.
So rounding that to three significant figures, what is it?
3.90.
3.90. Okay, because that 7 causes that 9 to round up, that 9 causes that 8 to round up, and you do need the placeholder for that third significant figure. So this is going to be 3.90 what?
Centimeters squared.
Centimeters squared. I'm talking about area. Very good. Now in part B, it asks me to find the length of AB. Okay, not quite the surface area yet, but each one of these pieces is building me up to that point where I'm going to end up finding the surface area of this figure. So, the length of AB is opposite of that angle 120. I can do law of cosines because I have two sides and the included angle in that triangle ABC. Okay? So I'm going to draw it really quickly off to the side. So we have B, C, and A. This is 3, 3, and 120. So yes, two sides and included angle, we are going to do the law of cosines. Okay? Which basically says that this side squared should equal 3 squared plus 3 squared minus 2 times 3 times 3 cosine the angle.
Can you also do law of sines if you find the angles for A and B?
You could use the law of sines because since it is an isosceles triangle, you could subtract that from 180 and then divide by 2. Yes. Okay. Let's find AB. Okay, not AB squared, but the actual answer for AB. Did we get an answer? Did you remember to take the square root? Because it would have been AB squared equals a number, you have to take the square root. So, did you get this number?
Yes.
Three significant figures would be?
5.22.
Very good. 5.20 centimeters. Don't forget your units. Questions? Now I can find the surface area of my prism. Okay? Because again, the surface area of any figure is really just the area of every single one of its faces. The sum of every single one of its faces. Okay? Now, when we look at this prism, it is a blank prism. What kind of prism is it? It's not a rectangular prism, and this becomes the issue, especially with these types. Because remember, a prism is named by its basis. And just because it's a rectangle on the bottom doesn't mean that it's the actual base. Every prism has two congruent bases that are connected by parallelograms. So it's a triangular prism. This one here is a triangular prism. Which means, depending on what formula we ever learned about surface area, okay, you're going to need to figure out the area of both of the triangles and then the area of each individual parallelogram that connects them. Okay?
Why is the parallelogram not a rectangle?
Hmm?
Isn't a parallelogram and a rectangle two different shapes?
They are quadrilaterals. They do have different distinct features. The reason why these are parallelograms is because we do not know for sure if at every intersection with the base it creates a 90-degree angle. But the area to find a parallelogram is the same thing it would be to find the area of a rectangle. What's that formula? Base times height. Okay? So we basically have two congruent triangles that we need the areas for, which we actually found in part A, correct? And then we have three parallelograms. Are these parallelograms all the same? No, they're not. The one that's on the bottom, which is formed by ABED, has a length of 5.20 and some change, and 4. Then you have ACFD, which is 3 and 4, and then BEFC, which is 3 and 4. So technically you have two parallelograms that are the same one that's a little bit different. So one way to find the surface area is to find the area of all 5 of those faces, the 2 triangles, and then the 3 parallelograms. Okay? So I'm going to show it both ways for this example. It's the only prism one that we have, but I'm also going to show you the other formula. And then I'll have these 3 parallelograms. One parallelogram, second one, and then the third one. So I need to multiply my area of the triangle by 2, which was that 3.90 number. Okay? Am I going to use that rounded answer? I'm definitely not. I'm going to use that non-rounded answer that should still be in my calculator. Then I need the area of one of the parallelograms. To find the area of the bottom parallelogram, what do I need to multiply?
4 times 5, 2.
The one on the side is going to be 4 times 3. The one on the other side is going to be 4 times 3. And then we just add those up. Do not use the non-rounded, do not use the rounded answer. Use the non-rounded answer when you're doing this. You guys get this number? Good stuff. So 52.6 centimeters squared, because we are talking about area. Even though surface area is still area. Area is always squared. Questions? So to find surface area, you find the area of all your faces and add them up. There was a formula that you probably learned way back in your geometry days to find the surface area of a prism. You can use either one of these. You'll still get the same answer. The formula is the area of the base, which is represented by capital B, times 2, plus the perimeter of your base times your height. You'll get the same answer, okay? But again, the big B represents the area of your base, which means you would need to know that is a triangle, not a rectangle. And then you would need to know the perimeter of your base. And considering that you know all 3 sides of this triangle, you could do that as well. You'll still end up getting the same answer.
You said perimeter times the height?
Perimeter times the height. So then the height would be the distance between the 2 bases, which would be 4. Okay? Either way, it would still get you the same answer. Pyramids. Okay? Let's take a look at this one. Again, it's building you up to get to the point where you're finding the surface area of the pyramid. Very rare they're going to ask you to find the surface area of a pyramid unless they give you everything that you need to know. Okay? In this particular picture, we know that this is a square base, right pyramid. O is the middle of the base. The sides of the base are 5, and considering that it's a square, that means that all sides are congruent, so they're all 5. And then we know that the height of the pyramid is 6. Okay? Now the only issue becomes is that when we're trying to find the surface area, which is part C, we would need to know the area of that square base and then the area of each one of those triangles. Okay? So, let's calculate the length of EM, where M is the midpoint of BC. Okay? So BC runs along the back of this pyramid. M is the midpoint, which means if it's the midpoint, it's going to do what to BC? Split it in half. So from B to M, how long is that going to be? 2.5. From M to C, how long is that going to be? From O to M, how long is that going to be? 2.5. Not a trick question. It's 2.5. Because if I take this from 3D to 2D, that is a square base where BC is 5, M is the midpoint, and O is located smack dab in the middle. And if it's located smack dab in the middle, it is still halfway along each one of those sides.
If they didn't tell us at the top that it's square based, would we not be able to make the assumption that M to O is 2.5?
Correct. Now they could not say that it's a square base pyramid, but then give you these markings. What do those marks mean? Okay? So then you would know that, you can run the same type of analysis. All right, so now that we know that, to find EM, what concept could I use to find EM? That does run along the side of that pyramid, E to M. And considering that this is a right pyramid, that means that E, O, and OM form a what? And this is nothing but a right triangle.
Where's O?
O is in the middle, the center of the base. So E, O, M form a right triangle because EO is the height of this right pyramid and M is the midpoint of that other side. How long is EO? 6. So then to find EM, I'm going to use what concept? Pythagorean theorem. Because I know two sides of a right triangle, and I know no angles inside of that. Okay? Yes, sir. 6.5. In part B, we need to calculate the area of triangle CDE. CDE. Do we know any information on that triangle?
All of this length height is 6.5 all the way.
So then, does that mean that
EE would be 6.5 and EC is 6.5.
because the distance, if we could have done a Pythagorean theorem with EC, but then it wouldn't have been with 2.5 because from O to C, that's not 2.5.
Okay.
Yeah, so we can't make that assumption, but we do know that running straight down the middle of triangle ECD is 6.5 because EM, which was that distance that ran from the vertex to the midpoint, is going to be the same on every single one of these congruent triangles. So here, this 2 is 6.5. And this, yes. And why is that? Why are all those triangles equal?
Square.
Because it's square. Had this been a rectangle, the two opposite ones would have been the same. But because it's a square, we know that all those triangles that form the pyramid are all equal, which means that all of those slant heights that run along the side of them are all the same. So we know this is also 6.5. We know CD is 5. And that is a triangle that we can find the area of using what formula? This one would be a base times height, because that slant height does create a 90-degree angle with that side. So to find the area, we will use old school 1/2 base times height. All the slant heights, no matter if it's a rectangle or a square, are going to form that 90-degree angle with the side. So what's half of 5 times 6.5? 16.25, and I am going to go that full distance because it ends at the 2.5, correct?
Why is the base 5? Oh, okay.
All these other. We can, but the thing is that considering that we're about to find the surface area of this pyramid, and that is the exact answer, we might as well leave it as the 0.25. And remember, 3 significant figures or exact. And so since it ends, that is exact. Yes? Because remember, it's a square base. So that means that AB, BC, CD, and AD will all be 5. Mm-hmm. So if I could have done this as 2.5 to represent this, and if I did 1/2 6.5 times 2.5, I would have only been finding the area of half the triangle, which means I would need to double to find the area of the full triangle, which is what I'm looking for here. Shouldn't be. So that represents just that 1/2 of the triangle. So then when I double it, I get the full triangle. So it's the same.
So on a test, if the number does end how it did with 16.25, we don't have to round it.
Correct. You can, but you don't have to because it is exact.
What if we go back to 3 decimal places?
Ooh. Mm-hmm. 3 significant figures or exact. Surface area of this pyramid is going to be the area of the base added up to all the areas of the sides of these triangles. The area of the triangles. And they're all equal. So we need the area of the square at the bottom. And then how many triangles?
4.
And they're all equal, correct? So how do I find the area of a square? Which is 5 times. Then we're going to do times plus 4 times the area of one of the triangles, which we just found to be 16.25. What do you get? Even? 90 centimeters squared. All right, for a cylinder, okay? The first diagram shows a cylindrical pencil container made of leather. The base diameter is 8 centimeters and the height is 13. If the base diameter is 8, that means that the radius is 4. That means that the radius is 4. Wow. Okay, did I ask you too fast? Is that why there was no response?
Yes.
I said the diameter is 8, the radius is 4. Okay? And let's just be real, anything that ever really involves a circle, bless you, we dealt with the radius, not so much the diameter, so we kind of want to always make sure we identify that. And now it says to calculate the area of the leather needed to make this pencil container. Okay? So this entire pencil container is made up of leather, and we need to figure out the area of, or how much leather we need to basically create this figure. Okay? So, what does that mean to you? When you see that type of problem, what does that mean?
You need the bottom base and the side all the way around.
Bottom base and the side all the way around. Okay? The top? Why not?
Because the pencil base.
Okay. Want to elaborate a little bit more?
You need a space to put the pencils into the case.
Why aren't the pencil cases that close too?
Well, it doesn't say it closes.
But it doesn't say that it's open either.
It's a pretty tall
So when you just
Yeah,
have
like
the
the pencil cases are usually just open like candy store.
Ladies, is your pencil case open in your backpack? Closes, right? So is it open or is it closed?
They're also not cylinders though.
Are you sure? It can be. I have seen some that are cylindrical.
And they
Mhm.
have the zipper on the side.
So,
Yes. Mhm.
trying to complicate things a little bit more. You know how with a sphere you said that whenever you cut it into two hemispheres, you're gonna have that flat side.
Mhm.
What if you were to do that with the pencil case that's hollow on the inside?
And then that's another question. Am I only looking at the outside? I'm looking at the inside too. Mhm. Getting y'all prepared for TOK, what's about to go to. You should think a little bit. Mhm. So now the question becomes, which one is it? Is it open? Is it closed? Is it the outside and the inside? Which one is it?
What's the inside wall?
Both. Well, not so much like the space in the inside, like the other side, like when you go into like the inside part, like around it.
You just multiply the surface area by 2 then, right?
Do I need to consider the inside? Let's start there.
No. It doesn't say it's the inside.
It doesn't say it. It does not consider it either. But when we create this pencil case with the leather, right? When we form it, whether we're considering the outside or the inside, isn't it still creating that case? So do I need an additional amount of leather to go on the inside? That outside leather will take care of creating that figure, that cylindrical figure. So we want to consider the inside. But that's a great question. If we were painting this, we would have to consider the inside as well. Okay, but we're not. We're just creating. Now, back to the question. Is it open or is it closed? All right. So we're going to go with it open, which means that when we're doing the area that we need, we're looking at the surface area, but we're not going to consider that top cylinder or that top circle. So to do this, we're going to need the area of that bottom circle, which is what? Pi times r squared. Okay? And then we're going to need to add it to the side of that cylinder. How do I represent the size of that cylinder? And this is what I was like, oh wow, they changed the reference booklet because this used to be in the old reference booklet. They changed the curriculum, so you're going to need to know this. How would you represent the size?
Would you need to find the circumference of the circle and then multiply that by 13?
And 13 represents the height, and that is exactly correct. To find basically the lateral area, the size of the cylinder, you need to take the circumference of that circle. Circumference is what formula? 2 pi r. So circumference of that circle, and then multiply it by the height. This formula right here is how you find the lateral area, in other words, the sides of a cylinder. What's the radius of the circle? 4. And then the height is 13. And plug it in. What did we get for our answer?
376.99.
376.99, which rounds up to be
377.
centimeters squared. Questions? Do we write that one down about the lateral area?
Yes.
Okay.
Wait, we have to subtract the area of the base.
We don't, because we only did one of the circles, not two of them.
That makes sense.
All right. Cones. Cones are comprised of a what kind of base? Circular base. So we need the area of the circle on the bottom, and then what's known as the lateral area of the cone. Now, isn't that formula in your reference booklet, the lateral area? Or the curved surface area of the cone? What's that formula?
Pi r L.
Pi RL. And what does the L stand for? Slant height. So in this picture, this was pretty straightforward. What's the radius? 3. And the slant height is 7. Remember, slant height runs along the edge of the cone. And then we just type that in to get our answer. Did you give our answer? 94.2 centimeters squared. You can either leave this as 30 pi centimeters squared, that is the exact. You just add the coefficients and leave the pi, or you can round it to 3 significant figures. That'll be your rounded answer. For this one, how can I find the surface area of this creation right here? What do I need to find the surface area of this creation?
You have to find the surface area of the cylinder and then the cone.
But you gotta be careful, because since the bottom of the cone lies on the top of the cylinder, you're gonna need to take away those circular bases. And would I even consider the top of the cylinder or the bottom of the cone at all? So I would need to consider them.
Only one time in
It's surface area. Would I even consider this part right here?
It's not surface.
We wouldn't consider that. So really and truly, we only need the what of the cone,
Slant height.
the lateral area of the cone. What else do we need? The lateral area of the cylinder, and then one of the circles. A circle with a diameter, that's a symbol for circle. Okay? So lateral area of a cone is pi RL. We just did that one. What's the lateral area of the cylinder? We just did that on the last question. Not this one, but the last slide. 2 pi RH. And of course the area of a circle, which is pi r squared. When you plug in all your information, your radius is, slant height is, your height is, and I have everything that I need. What'd you get? So then it would be what? 3 significant figures.
Oh, just centimeters.
Then we just stop at the 9. Did you guys get 119? So to finish this up, sphere, pretty straightforward. This form is actually in your reference booklet to find the surface area. It is 4 pi r squared to find the surface area. So really all you need to know is the radius. So you just plug in 1 for r, and you work it out. So now you could leave it as exact. Exact would be 4 pi centimeters squared. But if you type that into your calculator and round to 3 significant figures, you get 12.6 centimeters squared. Now for this hemisphere over here, if we were trying to find the surface area of it, we have to take into account that the bottom part here is half of the sphere. So we need to take half of the surface area of the sphere. So then that would just give us 2 pi r squared. But then we have to take into consideration that there is this circle that is also a part of the surface now that it's been cut in half. So things like I said before, you have a ball of butter and you cut it in half. Well, where you make that cut, there's that flat surface from that cut that you have to consider, which does indeed form a circle. So then you would need to find the area of that circle at the top. So half a sphere. So then that'd be 2 pi r squared. The radius is going to be half of 3, which is 1.5. And then we're going to add that to the area of the circle that's at the top, which is pi times 1.5 squared. And so then we'll work that out to get our answer. Exact would be 6.75 pi centimeters squared, but we would round that to 3 significant figures. If we wanted to get 21.2 centimeters squared. So sphere is pretty straightforward. You just got to be careful that when you are dealing with the hemisphere and it's asking you to find surface area, you want to take into consideration that that top circle.